that didn't work out. Wow. Little bit more duct tape and might solve the problem. Let's see. Yeah, well, it's my first time trying, so don't have high expectations, but have to try something. Well, yeah, everyone missed the start because I tried to put it a little bit quieter. Like so, I guess. Yeah, there's quite a loud background noise in that microphone, so it doesn't work nicely, but I have to do what I have here. No, it's not a desk fan, it's just electrical noise, because this here is my microphone and it's connected with a standard little cable into the front microphone plug in that computer, and it's noisy. Can't help it. So actually what I'm trying to do here is my upcoming video, what I planned what I'm going to do next is going to be about CUDA programming. As you know, the NVIDIA and those graphics cards, they have integrated. They nowadays have a system where you can program them and run code on your custom code on the graphics card. And if it's something you can run many instances of that same program at the same time, it's going to be much faster than on the CPU. So I'm thinking I would try to make some kind of a demonstration program of that. And actually it's based on something I was working on already. Actually put something here on my Twitter channel about it also. Yeah, this is as much as I said. CUDA programming with NVCC is surprisingly easy. This seems like a great topic to make a video of. So that's what I was thinking. I have the finished program. Let's see if I can show it somehow. Let's see. Delay. It's quite long. This is the program I was actually making, which is what the demo is going to be based on. Yes, CUDA. It's I don't know what it is acronym for, but yeah, this is actually what I was doing, and I'm trying to make a short little demonstration version of this. It's quite a long program like this to show, so I'm trying to condense the thing into a little digestible demo. So here's going to be a list of instructions I'm going to be using here. The main topic I'm doing here is, let's see, I'm trying to calculate 3502 assembler code that creates a certain number of clock cycles of delay depending on the contents of a CPU register. And I'm using a program that creates sample test programs in assembler and then runs them using a little emulator I have already here, this part, and then tests whether that program did what it is supposed to do, and if it doesn't, then it tries next program and so on. And the first version I'm going to use here is just running the program on the main CPU like you would normally do with C++, and then go on from there to show how it changes when it is made to run with QDOC. So let's see. Synthesizers work. Okay, then. Noise cancelling, I didn't know how they work with microphones. My videos on YouTube normally don't have this kind of noise because I do the noise removal in Audacity. I do it in post-processing. But when I'm doing live, it's not possible to do that kind of post-processing. This is actually Debian distribution, and the window manager is Cinnamon. All kinds of nasty pop-ups when I'm doing live streaming. So probably have some kind of upper limit here. Let's try it out. Yeah, it's actually quite hot here. 23 degrees actually Celsius right now. I should probably go outside instead of doing this thing, but yeah. Okay, so that test worked, so then I have to record the test did. Well, thank you for the sentiment. When it has synthesized that, then print the contents. music still too loud? Because my microphone is picking up the music and the music is also in the stream. There's probably some kind of echo there. Might be bad. Let's try taking that out. If that works a little better. I just run the code pretty frequently. If I'm working on a bigger project, then I make tests. Formal tests, but usually I don't. Okay, that should be everything. Have a try. Maximum, right, I have hard-coded that. Okay. Well, have to do what I have to do. So let's try with, I suppose 5 would be fine first. My first compilation for this program. What? Oh, okay. Typecast here. Return statement missing. Yeah, the text could be. Let's see if I can make it any larger. I'm not sure that really helped that much, but let's try that. Why did my Chrome window just die? What? That was unexpected. What? I'm not even sure I'm streaming anymore. Let's try with the other computer. Because my web browser just died. Am I live? Yeah, I'm still live. Wow. I really didn't expect that. So what actually happened here? this a hardware error or what? What's error? Well, I am out of disk space. Okay, that could explain something, but why did the kernel complain about that? x16. Yeah, I have saved it. That's all right. That's still there. I have multiple desktops, so that's not what is the problem here. But let's see. I was downloading something, so that exhausted my disk space. So that's one thing. But let's see. That way I get my disk space back. Now the browser should start. Yes, it did. Yes. Alright, I'm back. That was surprising. Let's try it again. So param is uninitialized. Oh. I think that's just a false positive, just in case. Yeah, the audio has lots of noise. I can't do anything about that. That's just this hardware. Alright. So the program runs for a long time. Without printing anything, that's what I pretty much expected. Something is wrong. It's actually not finishing this. Why is that? Let's see. Remove that. It got up to number 2 and then it jammed. Wow. So the branch is not working right. Yes, that's what is wrong. That's one possibility of how to do this work. Okay, now it works. So less printing, thank you. Yeah. Okay, but actually for this case I actually know already that it should be number 6. Length should be number 6. Not finding it. Let's try with some parallel processing. Upper limit is going to be, I could calculate it. trying to create a little sample program of CUDA programming. Good idea. Okay, that's why. Using 8 cores as it should, and it's not finding what I'm supposed to make it find, so let's see. If I take my other Chrome windows. I found it. Just a moment. Here it should be one of these. That's what I'm going for. It should be finding this code. And it's not. Well, if I take the microphone here, I can... Sorry about the noise. I can make the voice a little bit louder. Can you hear me better now? While I'm streaming, it's kinda hard for me to test the audio levels myself. Although it's clipping. Maybe let's try, yeah, little bit louder. Yeah, this could work. I suppose that's way better. Okay, so it's running, but it's not finding what it is supposed to find. Let's try without the ADC. Let's try like that. And actually print the upper limit. Okay. So it didn't find it. It didn't find. Yeah, the noise is nasty, but I can't do anything about it. It's there. At least I don't know anything I could do about it. Let's see. Yeah, something is definitely doing the noise. I don't know if you can see this. No, you can't. It's just below the camera. Okay. Well, this is my connection. This is the cable that goes from the microphone to the computer. There's this kind of clip here in between, and it could theoretically cause some noise. But I don't know. I don't have many alternatives here. As I said before, in my YouTube videos normally you don't hear this kind of noise because I remove it. I remove it in post-processing. No, it's not open broadcasting system. It's not caused by that. If I record myself in Audacity, I also get that kind of noise. So it's not that. The editor is Joe. Joseph Allen's editor. Let's see, this kind of editor. I've been using it for ages. So anyway, the program didn't work, so what is causing it? Yes, somehow power supply. There's one weird thing, because I have the server computer elsewhere. This is the desktop, by the way, that you people helped me to buy. If I take the audio cable from the server computer that is in another room, take the cable here, connect it into a USB speaker, and connect the USB cable into this computer, then the noise goes much lower. I don't know why that happens, but it just does. But I don't have the cable here right now, so Did it? Did it really? What? I don't believe that. I don't see any difference, at least in the audio meter. Don't know. Let's see if I touch that. No idea. No idea. No, Joe doesn't have that kind of thing. So at least if it does, I don't know about it. Actually should have H-top, let's see. Let's hear about H-top. Yeah, on board my sound card. Oh yeah. Well, this could be nicer. But I'm used to this. Woodpecker sound. Now you're making me curious. Let's see. Can I actually monitor myself? Hear myself? Let's see. Well, that's not too bad. That's not too bad a noise. I thought it's much more horrible. Russian woodpecker. So anyway, my code doesn't work. See, yeah, that's actually wrong. It should be like that. And actually, that's probably why it didn't find what it was supposed to find. Yeah, that's much better. Okay, so it finds, and what it should find is this. Or something similar. Yeah, that's fine for me. And it's +7. Yeah. Alright. Okay, we are getting somewhere. Japanese is a nice language. That's pretty much it. Okay, so that works, and it actually finds those pretty quickly. Okay, let's try number 7 then. 7, and length should be 7 because I remember it's 7. And what it should find is this. And it did find it. Let's see. BCS, BQ. Yes. BQ, BCC, BNE. Yes. It found it. Alright. What kind of penguin is that? I suppose you are asking about Linux distribution. This is Debian and the window manager is Cinnamon. Alright, so the program works, but it's so fast that it doesn't make a good demo. It should be a little bit slower. If I make a little bit more exhaustive testing, then the number of combination becomes like that, and that's a huge number. Yeah, it's a delay finder. Kinda obvious when the program name is delay finder and I'm showing 6502 assembler code here. And architecture is 64-bit Intel x82-64. Okay, sequence 9. 9 should not be found so easily. Okay, take care, Lucas. Okay, so that's as far as I get with. Yeah, that should take a long time. Although to be fair, I wouldn't use this kind of. Let's put that back to 265 2. So that's a much more tolerable number. Yeah, I will try CUDA there. So I have to change this into something that runs on both the host and the device. Same here. And here. And that's only host, and then I need then use NVCC instead of those, and run into some limitations. What? Let's remove that. Why am I getting that? What? Let's see. Next delay. Over here, my working example code. Host device. So it should be like that. It should work like that, but why is it complaining about that? For the moment, I'm baffled. Host device. let's see what else differs here. Nothing that I can see. Let's try without those options. Also compare the compiler flags here. Oh yeah, of course it's trying to compile it as normal C++ code. So that's it. Yeah, okay. So now it still should run. Yes, it still runs. And actually it should be possible for me to use OpenMP still here. Let's try without OpenMP to see how it actually uses CPU. Without that, 100, and with that, 600. Should be 800, but I'm having those broadcasting things on, so it's not so much. Okay, we are getting somewhere. So next I need an entry point for the CUDA. And actually I should have an entry point for CPU as well. I actually did so many times already. This is the program running here. And this was me compiling it, just typing this command. So it needs a place to put the results into. Sequence length and value. Then we need the entry point for that's actually host only. Well, I don't need to say test menu. Yeah, and then use make proc delay CUDA. This is what I do. I copy paste code from my earlier samples. So index is like that. Could be C here for consistency. And that should work. Yeah, it does. Yeah, it does run on that computer. But hello. So test menu. Let's discard that threading stuff for now. I still need that, so let's value is the first value and count is the block size. And here I need something and something other. Block size. size divided by number of threads. And that should still work. Oh yes, it does. But this is invalid because it's wrong kind of buffer. So I actually need this. Because the CUDA program cannot write into CPU memory straight away. It needs memory that is allocated from the graphics card. So again, let's use some copy pasting. CUDA malloc. That should be enough. And then CUDA mem CPU. Target is this, source is that, block size is the size, and direction is CUDA mem CPU, CPY, device to host. And then this is C++, but with some extensions like this that only compiles on CUDA. So it's pretty much C++. CUDA is pretty much C++ except some things where you say this function, for example, is synthesized and will run both on host and the device. And this one will only run on the device and acts as an entry point. So let's not use P for that. Report len variable C and results. Let's see, that should now work. Oh yes, it does, except it doesn't work because it works, but right. And just for profiling, let's see, 22% utilization. When I run this, it's 98%. So that proves it is doing things. About that. Because now I don't actually know whether this does what it is supposed to do. No, I don't think it is doing what it is supposed to do. Yeah. Alright, so that works. Yeah, that's the problem with integrated systems. I'm also hearing the noise in my television monitor. 4.2.0. Where did you see that? That's not 4.2.0, that's 4.5.0. Yeah, CUDA is NVIDIA only, regrettably. And was it OpenCL? OpenCL. Yeah, I think NVIDIA doesn't support this one. So now that it works, I should also run that same thing on the CPU. And I should also report the throughput. Let's try that. So 0.6 seconds. Well, actually, well, I don't know, 0.6, let's say 0.6. Let's compare it to the one that was written for CPU. This is not going to work with OpenMP. And also, just remove this. Yeah, this is not going to work. The return statement is not going to work. Let's try without that first. Is it actually even working? I don't know if it works still. Let's try that again. I'm trying to create a CUDA programming example for my next video, and the topic is code that tries to optimize and find 3502 assembler code that generates given number of clock cycles to delay. And there's some noise on the background, I can't help it. Let's see if I want to change the music. Why did this not work anymore? And anyway, I should do it in blocks. But before I go to blocks, I should still try to figure out why... Oh, of course, blah. So one CPU is about 2-3 times slower. Let's try again with OpenMP. Wow, that was low. Quite surprising. power cable is not near the microphone cable. The microphone cable is here. I don't know if you can see it. Now it's in my lap. So why did this become slower when I run it with one CPU 1.97 seconds and with 8 CPUs I get 3 seconds. Oh. Yeah, it could be, but it's easier for me to change it if it's like this, because it's just a temporary number. It could be like that. It doesn't really matter. So anyway, it works now, so I have to change it into using that test menu function that I created earlier. So block size, and I don't know if this works, just to see if it works. It actually works. I didn't know that. So the block, this needs to be larger. Each thread is going to need their own buffer. Try this. Okay, now it's faster and without the thread. 1.3 and 1.3, exactly the same. Well, that was also surprising. When I run this compiler, do you hear a noise? Let's see if I can see it on the monitor. Pause. I'm not seeing anything in the volume meter. Wait, this is the wrong version. So it's not while I'm running the compiler. One 1.3 with 1 thread and 1.3 with 8 threads. That's kind of disappointing. Actually, I was testing something totally wrong here. So this is actually with the CPU only. It's not working? C equals 32, where? The block size is this much. I can't remember what I put in the description. What did I put there? Ah, yeah. Okay. It's not finding the result. The CPU, I mean the GPU, let's see, that's what it has, 336. I don't know if you can read it on the stream, but that's what it has. Oh yeah, you asked about that Haskell. I have tried Haskell at some time, but it's got kind of steep learning curve, and I haven't actually found any practical use for it so far. It's kind of proof of concept to me. I know there are people who make stuff with Haskell, and there are some impressive creations. People have even created emulators with Haskell, and for parsers and stuff like that, it is. I hear it's quite an excellent language, but I haven't had a motivation to start learning it. I totally appreciate the what should I call it? Well, let's say I appreciate the courage to try something different, to go with a totally different flow with functional programming, when these are imperative programs that we usually create, and also that it's quite a lot prettier than Lisp and Scheme and so on. So this one worked, but that one didn't. Okay, I had here also the same mistake that I had in the other code. So let's try again. CPU 5 seconds. CPU 8 cores. Also 5 seconds. Not quite what I was hoping for. No, I haven't used J or APL. Yeah, it is 6502. I'm trying to create code that discovers this kind of functions, where you give the delay in a CPU register and it produces a number of clock cycles of delay that depends on that register. And these code samples you see here are what I have already found with a full version of this program, but I'm trying to condense the program into something that is going to make a good video, hopefully. If this doesn't work, then I'm going to try something else, but for now I'm going to try this. The system rating, the system number here, it tells how much it uses operating system facilities. And right here it's doing most in the user code, it's not doing things in the kernel code. For example, kernel code would be if it's trying to open files, trying to open sockets and so on, connect through network and transmit data and so on. If it's busy doing those things, then it's system bound, but this is user bound. And this elapsed number here is the total of these two. Yeah, it's kind of minimal C3502 emulator. It only supports these 6 opcodes here, or which I explained here, because it's only optimized to find a combination of these opcodes that produces the certain number of delay. So it only tries these 6 opcodes. But yeah, it's an emulator in that aspect. Very minimal one. But why is it not scaling? Maybe if I try a smaller block size. Eight threads. 5 seconds again. And 1 thread. Still the same. Why is that? Well, at least so far we know that when we run it on the GPU, it's a lot faster, 5 times faster. Even though this is not optimized for GPU at all. GPUs are horrific, really bad at processing branch instructions. Branches like switch cases and whiles and loops and ifs and so on, where the execution may take one path or it may take another path. And they are horrific at that. It's really bad, and it's still 5 times faster than with the CPU. According to the CPUs that were... Oh yeah, here. Let's see. If I use this and show when it's running. You're right. You are right. Let's try this. Okay, so even though this compiles, the NVCC is ignoring it. Okay, that explains it. Yeah. Yeah, they are. The main challenge with emulators is accuracy. Because you have to know everything. You have to know everything about how the platform, how the hardware works. You have to know every detail. And when there's many components acting together, it gets really complicated. And there's corner cases. There's lots of corner cases. And some games don't care about those corner cases, or they work by accident. But in many games you need to take care of those corner cases. I haven't actually done any shader programming yet. So anyway, I can't do threads with OpenMP here, so I have to use C++ 11 threads. And that's going to get complex. Already did it, so I did use the threads here, which is my complete program. But it's a little bit complex, and I want to keep my videos simple. I realize that's really a sliding scale, but I try to keep them simple. At least I try to keep them short. No idea thinking. Is there any one in progress? Let's see. Xbox One emulator. It says there's some. I wouldn't try it, but yeah, they say it. There's one. Let's see, PS4. PS4. PCX. PCX is 4. Well, there's some working. Okay. I would think as much. Okay. That's why I said I wouldn't try it. So anyway, I need those threads here, and what would be the simplest way to do that? Well, I could do this. Let's try a really stupid and simple way first. And I need this vector. C value. So that would be the crude way to do it. try that. Something's missing. What? Modifiable. Okay, it doesn't make an actual variable here. Don't have the cat anymore, sorry. Without the GPU. Alright, 1.97 seconds. .97 and with one thread. Five seconds. So it's 2.8 times speed increase by using threads here. Not quite as much as I hoped. CPU 58%. Well, I need a much bigger size block. Yeah, that helps a bit. Let's try even bigger. Yeah, that really helps with the scalability. Flushing, do you mean this? Yeah, that's true, that's actually true. Yeah, it affects a little bit. And if I run these both, well, they are run in sequence, so that's no help there. I actually did overclock this machine a little bit. This is what I have here. It's supposed to be 3.7 gigahertz, but it's 3.9. And memory speed is supposed to be 1600, but it's a little bit higher. That's as far as I dared to go. Yeah, that's what it does, Perplexed. How does this actually work in comparison? That's okay. This tracing. Can I change the updating rate somehow? Delay one. Oh, in tenths of seconds. Okay. Okay, I saw 507 there. Well, some Xeons do. This is actually pretty much comparable to some i7 product. I don't remember which CPU. I was actually going to get i7 46 something, if I remember correctly. But someone in IRC told me that Xeons often come with smaller price and more performance, so I studied that. And I made some comparisons, and I went to Amazon, and I went to eBay, and I went to AliExpress, and so on, and I used this excellent Intel website, arc.intel.com, which lists the different CPUs and compares them. This is the one that I have actually, and I used it and did some price comparisons, and I ended up with this. The main selling point in Xeons, if you don't go to the very high spec Xeons, is which also of course have those obscene amounts of cores, is that well, they don't have integrated graphics, which puts the price a little bit lower, but to compensate, the prices actually are a little bit higher, and it's because they support things like ECC memory, which can detect corrections and to some degree repair them, and some other interesting features. But in desktops, it's really not something you should care about. But especially for those older processors, Xeons can actually be much more cheaper for the same performance than the desktop marketed ones. Yeah, and they also, some of them cannot be overclocked. This one should belong to the category that could not be overclocked, but it actually can. I don't know why, but it actually can. If I compare these two, let's see, compare with formerly Haswell. Let's see. Desktop. If I can see which one was what I was going for. No, not there. I can't actually remember. 4 point something it should have been. Oh well. Well, it in any way it comes pretty close to in the comparisons. Yeah, some Pentiums and older processors also support that, but Pentium was before they began the Xeon branch. Let's see. If you look at these CPUs here, some of these really have those obscene amounts of CPU cores. Like this one, this has 18 cores. Mine is here, just 4 cores, which are hyper-threading, but they are still 4 cores. So compared to this one, which have 18, it's quite different, but the prices are also hefty. So no way I'm going to get that kind of CPU, at least until their prices come way down. But I don't like to get the newest of new hardware, because the newest of new always have sky-high prices and it's not worth it. This is pretty new what I have here, but even the graphics card, as you saw earlier, it's not the newest one. It's GTX 560 and it's been out for quite some time already. And I didn't actually buy this, I got it donated from my friend, so it was also cheap for me that way. So, threads. So now what would be the most efficient design here, which runs the threads and also the GPU? Let's try this. If C is 8, and then use this here. Could actually have this. That could work, and then I don't actually need to have that, so I can simplify it in that way. And actually it's simpler if I do that way. Let's try that. $1.25. Still not the most efficient way, because if I look at the GPU utilization, it didn't go really high. Let's use a little more complex task. No, this is Debian, but it is Cinnamon. Yeah, the GPU utilization is not really high here. Let's try different size blocks for those. And also I should do this. Free the memory after it has been allocated. GFX block size there. Bah. Okay, it works, I suppose. And it's again faster. If I decrease this even more, oh yeah, it's getting faster. The editor is Joseph Allen's editor. This one. That's what I normally use when programming. Oh yeah. So this could work. It's kinda long still. I'm not sure if I want to go with this example program. If anyone has better ideas of an example program, how to demonstrate CUDA programming. I was thinking about something graphical, but as CUDA is associated with a graphics cards, doing something graphical would be kind of conflicting, because when you bring graphics into the equation with graphics card, you kind of ask the implicit question there, why do you not do the graphics with the graphics card? Why you just do the logic with graphics card? So I don't want to do something graphical, but I want to do something that requires calculation and yeah. And this is what I came up with. I don't want to do fractal, it's so cheesy. I don't want to do live simulation. I was trying to think something physics related, but with physics related you need to also think about graphics and presentation, so it doesn't work. Well, I said already I don't want to do fractals because it's so cheesy. And also, if you're going to do fractals, then you already have fractal example in the CUDA example programs. If I can find CUDA, would it be doc? Yeah, examples and come on, no. Yeah, here's an example of CUDA example Mandelbrot fractal generation. So I don't want to do that. And now I don't want to touch Bitcoin anymore. And with mining by Bitcoin, it would be so unlikely you find anything interesting to showcase in a video. Prime numbers. Prime numbers could be something. It's kind of boring, but I have to think about it. Yeah, I know I don't have to use GPU for image processing and graphical things, but it still begs the question. I think it comes too close. And also with image processing, there's also the issue that when you install the CUDA system, you get a huge number of all kinds of include files. These NPP things here, these are all from CUDA, and this mostly deal with image processing. And I really haven't studied what this contains so far. If I do image processing in CUDA, people are going to ask me, why don't you use that and that function which already exists and does exactly what you want? And I don't want that. I want something that isn't already there. Raises the question, begs the question. Well, thank you. Ray tracing is also graphical. Ray tracing was actually what I first thought of, and it parallelizes really nicely. So in that way, it would be a really great topic, but it's not very approachable. There's lots of mathematics in there. I already made a ray tracing video once. This is my ray tracing video. Which I did once. And the thing is, there's so much mathematics in there that it's not really approachable. I don't know anything about soft body simulation. Never have done this. No, I don't use AdBlock here. I don't think I have any extensions here. In the, let's see, settings, plugins, extensions. Yeah. Don't have AdBlock here. Sometimes I use it, but I haven't bothered installing it here. Yeah, that's horrible. It's also horrible when people comment on my videos and I have to watch my own video to comment on it. Well, I actually can pause it, but anyway, I have to load it. And if there's ads, then there's ads, and it's kind of nasty. Of course, I also have the local copies of my own videos, but yeah. Yeah, I can change the music, sure. So currently this is 200 lines. It's not so bad. No, I don't have bookmarks. If I went this with face, 200 lines is not so bad, but I still need to make it smaller. This fits nicely in one screen. This fits nicely in one screen, but it doesn't look nice. I don't know if there's an API for comments. There's an API for videos, but I don't know if there's API for comments. The desktop is Cinnamon. Yeah, I am familiar with the Queen's problem. Actually, I know it from IOCCC. Source code for Windows has been released. Wow. I should look at this. Let's see. Be right back. Let's see, what did they have there? Tab. Yeah, I also use tabs as bookmarks pretty much. Sometimes I forget those old tabs and so on. Let's see, most diffused reaction. I'm just skimming what is in the newest IOCCC. Well, I do type fast. You saw a video in which I type. What? Ah. Clever. And that's actually syntax highlighting there. Wow. Okay, that's different. But I don't think the Queen's problem is very interesting. It's kind of do once and then it's done, solved. Recall the... Actually, I'm going to use a little bit larger font for this. No, I don't think it's cheating. Illegal instruction. Oh, I don't have indent here. Can I do this? No, I can't. Let's install indent. Oh, that didn't really help as much as I expected. Well, I don't know what I expected here. What does it do? Okay. No, I didn't create Joe. I didn't create Joe. Joe is someone else's. What I created was the DOS-based editor. I don't need to scroll down. I don't know if... When I last I watched someone else's live stream, I think the newest comments appeared at the top. I don't know why it doesn't do that for you. Oh, I see. I see. So it's an emulator. Yeah. Would you have ever guessed? This is an emulator. Support 6 instructions, 5 addressing modes, this one-liner. It kind of does factorialization here. Nice. Yeah, I'm trying to get some ideas for CUDA Pro projects. I was thinking of some kind of simulation of physics, like snow, water, sand, kind of rain kind of things. Something that would be simple enough, but the problem is graphics. You have to present it somehow. And when you have to present it somehow, you need lots of code for presentation, and also because you are doing things with graphics card, it begs the question, why don't you do the graphics with the graphics card? That's kinda not what I do. Yeah, there's some hum on the microphone, I can't help it. Okay, that doesn't really look obfuscated. Except for maybe that kind of thing. Well, that's surprisingly normal looking program for IOCCC. Base 16. All right. I have no idea what that is. No idea. Well, if you do graphics, it takes code. It's not. It really depends, but it's not simple. Usually, it's not really simple. Okay, I think I have different encoding here. I'll look at that later. So let's back to that. This. It's actually getting dark here. Hold on, I put some light. Don't know how the colors changed. Oh yeah, I'm so yellow. My hair is disappearing. Well, can I change my color a little? Okay, that's kind of horrible. Yeah. My green screen is showing through. It's kind of not very nice, but yeah. Oh well. So if I went with some kind of simulation, here I'm simulating 3502 with a reduced instruction set, supporting just 6 instructions. I actually have considered writing an emulator for some more complex system, and actually in my YouTube videos I have actually created the Microblaze emulator one time, which runs Linux and also advertisements. It's a little bit more complex than the Nintendo, but let's see, I was actually at some time I was working on a PlayStation emulation. If I can find it. Hold on. Go to try. No, that's not it. Let's see. It's not there, is it? Okay, it's in a different location. Yeah. So I was actually working on this PlayStation emulator here. You can see my CPU implementation here. It also does things like perspective transformation and graphics related things. And it's kinda long and boring and complex and so on, but eventually I abandoned the project for some reason or another. This SPU is not mine. Sound CC, it's not. I only have the memory there. Yeah, I think it's Studio Ghibli. Yeah. So I have tried PlayStation emulation at some time, but I didn't finish the project. Kind of exactly because it was too big a project. So much work to do before you get any kind of reward. and I'm not really, I just found some documentation on the architecture, but I don't even know how to debug it if I should need to. Yeah, the difference is there's tons of documentation for the 3502, the whole NestDev wiki, and let's see if it loads, which this thing I use it so much, and nowadays I also maintain it. Help right there, some kind of things. I don't know good books on CPU cache, but I know that excellent memory article in which was in LWN, what every programmer should know about memory. I really recommend this article. This teaches a lot about CPU caches, RAM hardware design, memory controller designs, and so on, and how those all integrate and work with each others, and what does it mean for programmer and so on. It's 9 parts, so it's really long reading, but I really recommend it. You should take a look. 日本語は私はあまり日本語を話しません。That was because he asked about Japanese. Yeah, I use Chrono Cross, and sometimes I use some Super Nintendo soundtracks. This is kind of my selection of what I sometimes have here. But I use this Chrono Cross soundtrack basically the most nowadays. Domo arigato. What is that PDF? Oh, is it the same? Yeah, it's the same article, except in PDF form. Wow. For Japanese, I use this website. Its IP address URL changed it sometimes, but how I got started was with this website, MacTOS. Japanese is possible. If it loads, yeah, this one. That's how I started. And then I went to what is it called? Workers Night School. I think it's called Night School. I went there for a couple of years for Japanese. I'm basically a grammar person. This website begins with teaching grammar, and it's really what I loved doing. So that's how it was easy for me to do. I don't have many vocabulary of many words, so that's kind of my lack there. And then I created some tools to aid my studies. So no, not that one. This one, kind of like dictionary here, Kakashi. I created a dictionary and some tools for conjugating verbs. Hanashimasu, hanasu, hanasu, like this. Things like that. So I could help study that way, and I could possibly help others. That's why I created it. That's because I have found that teaching is the best way to learn. So to teach myself and possibly teach others while I am doing that. Jozu. I don't think it is spelled that way. It should be Jozu. Jozu. Like that. But thanks anyway. And yeah, I know some Hebrew, but I'm not conversational in Hebrew. I just know some prayers and stuff in Hebrew. For example, I could say the blessing for bread. Baruch atah Adonai Eloheinu melech haolam hamotzi lecha min haaretz. I could say things like that, but I don't really know that language so much. Jag talar inte svenska. I haven't done anything to this program for like an hour. Should do something, but I'm still divided on whether I should go with this or think of something else. Well, that's the problem. I don't really. I usually start something and create a lot of code in one day. If I don't continue it the next day, I probably won't continue it ever. There's also that problem. I will show you something. This is what I have been working on for a while. Let's try that again. I kind of lost myself here. Let's put myself back in bounds, because it's working way too fast on this computer. This is going to be one of my future videos, but it's working way too fast here. Let's see if I can resize the window. I can't remember whether I can. Well, I can, but it doesn't really help. This is the natural extension of the 3D engine I was working on earlier, except it's fully 3D this time. It's not Doom style, it's fully 3D. And you can see it's this much finished. Yeah, but this is not the Yeah, this is not the thing that I featured in my previous video about the Doom style, because this is not Doom style, this is full 3D. And this is what I have been working for quite a long time already. And what I have here is tons of C programming code, which is quite long for one video. And getting it to smaller size has been something I have been aiming to do, but which I am not there yet. And also there's lots of mathematics here, which is quite nasty. I am pre-calculating the light maps here. I'm using the Hemi-Cube algorithm. Pretty much going to each pixel or luxel in the texture, putting the camera there, rendering the whole environment, what it sees from that point, and taking the average of that and using that as the luxel, and doing that over and over and over again. And that's how I do the light maps. It's pretty much how everyone does it nowadays. I had actually here another, no, not that one, another test. Let's see if I can find it. Project Synchrono. Was it this one? No, it wasn't this one. Something I showed me in my YouTube video, but let's see. No, not YouTube, but I mean in Twitter. I can find it. Let's see. Here, a screenshot, 2 walls. Here. This one is actually the same engine, pretty much, but the difference here is that this calculates the light maps in real time, and also the light sources are moving. So the algorithm can actually work in real time, but it's not really fast. At least if you try to do it on the CPU. This is actually something that would be interesting to see how it works on if I use it on GPU with CUDA sometime perhaps. But anyway, it's doable in real time. I don't know if it's going to get recorded. I suppose it will. I don't know if I get to say anything about that. In this one the lighting is dynamic. If I increase the resolution, maybe it's clearer to see. Let's see. I think this is the main program. We do it. If I can find the width, the specification somewhere. Oh, over here. Let's increase the resolution a little bit. Ouch! Well, that wasn't quite what I expected here. Why is that? Well, anyway, let's try with another machine. Wow, I really didn't expect that. Guess I won't show it then. I think YouTube live streams are recorded, but
I don't really know. Algorithm, I think I need that one. Accumulate. Huh. Where is std accumulate? It is in algorithm. No, it's in numeric. Okay. Let's try again. Okay, it works that. R&D. Random. Get Z. Why? Why is that? Yeah, it's not really a practical solution, especially if things move like they do here. If they are static, it works really nicely though. And especially when the light map resolution is as low as it is here, you can kind of see it's not really many pixels here, but here it's pretty nice. The walls are single color here, so the and the walls are rendered in the different order here. This was actually a demo I created to showcase different ways to sort the walls in. If you wanted to try Painter's algorithm, it's not so simple to sort the walls. If I try this closest vertex, it changes the order here. It's kind of the same thing that I was telling in the beginning of that Doom video. You can see it's kind of different. So anyway. This is the problem with leaving your programs for a long time and not verifying which include files you required. So on. You get bit rot. By the way, the include files here shared. Yeah, they are shared. So that's also a reason why I'm not. Yeah, because they are shared between that other project. Okay. It takes infinite bounces per surface. Literally, it's infinite. It's continually rendering those light maps. Every time it renders that wall, that wall, that wall, that wall, and back to that wall, that wall, that wall, that wall. And the more times it does that, the better the quality becomes. And it doesn't matter that the lights change and the walls change and everything can change. As long as it keeps doing that, it always getting progressively better. Every time it does it again, it gets a little bit more of the reflections from other walls. Yeah, it's progressive. In the demo that I am going to do for YouTube, which I showed earlier, it doesn't render them in real time because there's like 400,000 polygons there. It doesn't render them in real time. It does it in advance, but it stops doing them once the difference between previous round and the new round becomes small enough. That's the same way that Valve's VBSP VRAD does it also. Yeah, it's more processor friendly to take few samples. And actually, the samples here are actually as I said earlier, it renders the surrounding, and people usually do it with a hemicube, which is like a cube but cut in half. Let's see if I have an example here. One over there. So let's see if I can bring the Wikipedia articles here. Well, that's not really a clear representation. But anyway, if you think about the surface here that you are going to project the light, you kind of put a half cube on the surface, so it actually goes in the middle here, and render everything on top of each of these walls on the cube. So you kind of put the camera on the surface here and then render everything you can see on this surface, on this surface, on this surface, on this surface, and on this surface. And from those surfaces you take the average, and that becomes the pixel. But how I do here is actually I don't take a cube there, I take a decahedron. So it's 3 triangles, was it 4? Instead of four squares, 5 squares, instead of 5 squares, I take 3 or 4 triangles and use those, and it's a little bit faster. Yeah, it's leave. I don't need to take initial guesses. I just start with black. Yeah, it would converge to the final solution faster if I made an initial guess there, but there's no reasonable initial guess. Well, you could possibly take the middle point from that surface, render one view from that middle point, and then color the whole polygon with that color. But that's only the first time around. Especially if you're updating the light maps in real time like I did in that other demo, then it's not going to be worth it. Because as you saw here, you don't get to see a situation where there's nothing in the light maps. You just don't get to see it's fast enough. When you react that the window is there, it's already doing the second or third round. Yeah, of course you use the solution from the previous round. And actually what it does here, it renders pretty much pixel at time. And you can see it's actually rendering all walls at the same time. You can see how it's doing. You see it's scanning from up to down, and it doesn't discard the previous polygon. It's just overwrites 1 pixel, 1 pixel, 1 pixel, 1 pixel, and so on. It keeps the previous pixels in whatever it hasn't calculated yet. And it works pretty nicely. You can see some, I don't know if you can see it in the YouTube video, but you can see some artifacts here, some kind of grid pattern here in the floor. It's because the resolution is just high enough that they aren't too distracting. Yeah, I suppose so. Yeah, I suppose you could. It's only when you get to things like shadows like this one. The floor here is one whole square, but on the other side of this wall it's black, and the other side it's not black. And you can actually, where the wall is here diagonal, you can actually see that it's kind of pixelated, the difference here. But with shadows you cannot, if you want to do shadows, you cannot just do 5 samples and be done with it. So that's something I'm working on, but there's so much code here, and it's kind of difficult to put it in a YouTube video, especially knowing how usually in my YouTube videos I try to keep it in a 900 lines or less. Yeah, kind of decent like. Let's see if I can compile this. Here, I can compile it there. Okay, then I'm going to change the initial begin scene. Yes, this here. YouTube doesn't let you link, but I saw people pasting links here earlier. Let's see again. Yeah, I did get a new computer. This is the new computer. Thanks to my supporters. So this is actually how it looks without light maps, and this is how it looks with light maps. There's actually still some problems here. In some angles you can kind of see the edges between polygons here. The light maps are not really very precise here. I'm not sure what causes it, and also you can see here, I don't know how I can show it to you, but in the between of those two walls there, you can kind of see a black dotted line there. In my polygon rasterizer here, it kind of leaves some edges there sometimes. I think I'm going to leave those problems and bugs there, but until I can think of a solution to them. But yeah, it's not perfect. There's also some aspect of HDR here. As you can see, when I look at something dark, it gets brighter, and when I look at something bright, it gets darker, and so on. This was fun to code. It kind of leaves some shadow pictures here. If you look at that bright thing in the floor, and then turn the camera, you can kind of see it in the shadow after image of it. Yeah, it's intentional, it's perfectly intentional. If I disable it, you can see quite a difference. If I disable that. Just a moment while it compiles. Done compiling. So how it looks now. Loading. Yeah, I have made. Okay, now it's without HDR. Oops. So without HDR, you can see it's kinda intolerable at times, because you can't really see anything. Because it's too bright. That's why HDR exists. So when things are bright, it compensates. That's the kind of the whole thing. I also made it so that you can actually adjust these settings here. If I make the HDR here a little bit more aggressive, you can see some differences. I'm using SDL2, nothing else. Alright, so it's got now a much more aggressive HDR. I don't know if you can see the difference here, but if I leave the camera like this for a moment, you can kind of see a gloom. And if you look at these walls here, you can kind of see the edges are kind of emphasized there. Yeah, that's what I said. Let's see, let's go here. The after images are much stronger now. And this is the same machine you saw in the OpenGL demo earlier, but this is done completely without OpenGL. I don't remember where I got this shirt. So yeah, that's what I have there. Where was I? What kind of music do I usually listen when I'm programming? Well, you are actually hearing it right now. I usually listen to something from video games. For example, this is from The Longest Journey. This is sometimes what I have in the background. Let's see if I can... There's a little bit echo there, I think, now, but... Well, thank you there. It's all in software, yes. The only library I use there is SDL2. And of course whatever the standard library offers. No, this is not live ray tracing. I was just showing what I'm working on today for the extension of the portal rendering thing. Let's see. The previous video, this one, it's basically the extension of this one. This looks kinda so crude in comparison. But yeah, it's the same idea. I just applied it in 3 dimensions. So that's what I was working on. Let's see. Still intending to do a proper video of this 3D engine at some time, but just need to figure out how to make it smaller, more relevant. And for my next video I'm trying to create some example of CUDA programming, and still trying to figure out what could be a sufficient nice topic for it, and someone suggested ray tracing, someone suggested physics engine, physics simulation, someone said fractal rendering. I'm not going to do that. And what I have here is optimizing NES instructions, finding a NES instruction sequence that produces configurable number of clock cycles of delay. And that's what I thought of, because that's where I actually used myself. I used CUDA for that. So that's that. What else? Yes, that's all C++. What else have I been doing here for YouTube videos? See. The problem with physics is that it's mathematics heavy. It's kind of difficult to make it interesting. I don't personally think mathematics is very interesting. Yeah, I think I have exhausted the topics for today's video. There's still work to be done with this CUDA, this delay finder program. I should make it a lot smaller and more concise. This part here, for example, it has got so much duplication here. And possibly make the topic a little bit more approachable to viewers. If I'm going with this. If I go with something else, then it's a different thing. If I go with something else, you are probably going to see that video as a live stream. No promises here, but might be possible you are going to get to see that live stream where I make that video, but let's see. I think that's all for today. Let's see if there's any questions I forgot to answer before I sign off. Vulkan API, I haven't studied it at all. I don't have anything to say about Vulkan. I don't know anything about that. Sorry about that. The after images in the rendering were caused by the brightness changes, because it's adapting the contrast locally and globally. So it's kind of difficult to explain, but that's kind of what HDR is doing when you apply it to moving pictures, and it's actually kind of what your eye is doing. It's simulating what your eye is doing, and why do what your eye does? Why do that on the computer display? That's because the computer display can only display so many colors. It can only display so much light, or so dim light. It's got a limited range. That's why you have to compress the dynamic range and kind of do what your eye does. Someone said about music something. How synthesizers work and mixing for some video game using format. I have also done that. Let's see, traits of cave stories, synthesizing music. Where is it? Yeah, anyway, in this video I kinda showed the basic of synthesizing some music. I used the Cave Story synthesizer here.
Requested play.
Let's see. If you haven't watched it already, go and watch it. It kinda contains that topic. Synthesizing music and showing how to create a music synthesizer. I'm not very proud of my narration in that video, but yeah, it's done. It's done. Let's see, what else did I not answer? Bump mapping. Bump mapping, I actually tried bump mapping, but it's too complex on the CPU. It brings the performance down. It's only possible with shaders. Except if I discover something really clever. But with just the CPU it's too complex, bump mapping. Okay, I think that's all for today. So, thank you everyone for your support, and I think no promises here, but I may do another live stream in the future about making a video. This was about making a video and some other chat here in with it. So, thank you. Bye.